So this is chapter 9 of class 11th and we are talking about sequences and series. What are sequences? Anything which are in pattern or being arranged. That is, they may have something in common, like the population which is increasing in every year or every 10th year, bacteria increasing. Say a bank you have deposited, that money is increasing. That sequence or that amount they are just being placed, this is a sequence. This is what we call as a sequence, and Fibonacci he studied a lot about this. So sequences, they follow patterns. If sequences follow patterns, then these patterns, right, those sequences which are following patterns, they are known as progressions. So we have already seen in the previous classes the AP, that is the arithmetic progression, and here we are going to talk about arithmetic mean, geometric mean, the relationship between A and GM, and some special series, sum of some n consecutive natural numbers, sum of n terms of squares of natural numbers, and cubes. So sequence, just consider that you have a generation, and each generation gap of your ancestors, they are considered to be 30 years. So you, your parents, your great grandparents, they all have a sequence, and you vary by 30 years. In the similar fashion, say you have these number 10 by divided by 3. So you have 3, 3.3, 3.33, 3.333. All these are the sequences. These are sequences. So if you take A1, A2 till AN as certain numbers which are following certain criteria, and these are the terms inside this, we call them as a sequence. So this AN is the nth term, A1 is the first term, and the term of say this series, as you can see, the first is A1 is 2, the second A2 is 4, the next one A3 is 8, A10 is 1024. Similarly for this, A1 is 3, A2 is 3.33, say this one A point, any sixth you can take 3.33333. Now these are the finite sequences. There can be infinite sequences also. If you don't have a finite sequence, you will have a infinite sequence. So just consider this one. A1 can be written as 2, that is 2 into 1. A2, that is 4, can be written as 2 into 2. A3 can be written as 2 into 3. A4, 2 into 4. Some numbers say A24 can be written as 2 into 24. So here you find that this AN is nothing but 2n. Everywhere you see 2 into 1, then 2 into 2, 3. So this is a sequence of natural numbers multiplied by 2. Again, if you have odd numbers, then 1, 3, 5 like this. So you can say that AN is 2n minus 1. Here similarly, AN was 2n. AN was 2n. This was 2n. Similarly, you can have 1, 3, 5. These in odd numbers in order or sequence. These are having AN as 2n minus 1, where n is the natural number. You also have an arrangement where you don't have any visible pattern, but still there is a pattern. Means 1 plus 1, 2. 1 plus 3, 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8, like this. So if A1 and A2 are 1, then this A third is the summation of the previous two. Like the A1, AN is the summation of AN minus 1 and AN minus 2. This is called the Fibonacci or Fibonacci series. Right? So this is how you deal with the sequences. You have A1 to AN, and this sequence, this can be regarded as a function whose domain is the set of natural number, or say some set of a subset of this 1 to k, and also we call this as a function notation AN for this AN. So the series, this A1 to AN, if it is a sequence, then the expression A1 plus A2 plus till AN, These are the expressions. These are called as the series associated with the given sequence. So the series is finite or infinite according to whether this is ending or not ending. Then also we have one more thing, sigma. When you have a sequence, and when these sequence terms are added, we call them as a series, that we have known by now. Sigma means the summation or the value. It signifies or it indicates the addition. That is ak for k equal to 1 to n. This is actually showing you a1 plus a2 an, and this is actually giving you the answer, or it is indicating you to the value. Say some value addition is there, say 1357. So it refers, when we are using series, it refers to the indicated sum, not the sum itself. Indicated sum. For example, this one is a finite series with 4 terms, and when we use the phrase sum of series, we mean that the result from adding the term, that is the 16 of this. Let us consider some example. We need to write first 3 terms in these series. So an is 2n plus 5. Just write n equal to 1 first, then 2, then 3. So n equal to 1 means 2 into 1 plus 5, that is 7. a2 means 2 into 2, 2 to the 4, 4 plus 5 is 9. Then 3, 2 to the 6, 6 plus 5 is 11. And then this is an equal to n minus 3, just place 1, then 2, then 3. So we place 1, it will be minus half, 2, it will be minus 1 by 4. If you place 3, 3 minus 3 is 0, so you will get 0. So what is the 20th term of this sequence? You just have to place n equal to 20 here. So 20 minus 1, 2 minus 20, 3 plus 20. You will get minus 7866. Next is, let the sequence an be defined like this. a1 is 1, an is equal to an minus 1 plus 2, for n anything greater than or equal to 2. So you have to find first 5 terms and write corresponding series, that is a1 equal to 1, a2 is what? a2 is a1 plus 2. So a1 we have just got, it is 1, a2 is 1 plus 2, that is 3. So a3 is now a2 plus 2, a2 we have just got, that is 3. 2 plus 3, that is 5. Likewise. So these are the first 5 terms of the sequence, like 1, 3, 5, 7, 9, and this is the corresponding series. How about arithmetic progression, AP? And you may recall what you have studied earlier. The sequence A1 to AN is called the arithmetic sequence or arithmetic progression. If AN plus 1, the next one is the previous one plus some D. What is this D? This D is the common difference, or an is the term previous to it. So a is regarded in this series, a1 is regarded as the first term. This d is called the common difference. So if you consider in the standard form some values to be are in this form AP, so the first term will be a and the common difference d, a plus d, a plus 2d, like this. So first will be a, then a plus d, because if you subtract them, a plus d minus a, you'll get d, and in the similar fashion a plus b, d, a plus 2d, like this. So the nth term, or a general term of the AP, an, is equal to a plus n minus 1 into d. So what we can verify, the properties, if you add in this is a sequence, you add anything, say constant c, add anything to all the members, nothing will change. Subtract c to all the members, nothing will change. Multiply c with all the members, nothing will change. Divide c by c some constant, nothing will change. So if we take a as the first term, l the last term, d the common difference, n the total number of terms, Sn is the sum of first n natural or n terms of this AP, then a plus d, a plus 2d till a plus n minus 1 into d will be an AP. So last term will be a plus n minus 1 into d. Sn would be n by 2, 2a plus n minus 1 into d, and also Sn is equal to n by 2 a plus l, first term plus last term. Let us take an example. The mth term is n, so a plus m minus 1 into d is equal to n, am. Nth term is m, so an is a plus n minus 1 into d, and you can solve these two so that you can get these values like a is equal to n plus m minus 1, and also you have to find the pth term. So pth term will be what? A plus p minus 1 into d. You place a, this value here, and you get n plus m minus p as the pth term. How about example 5? If sum of n terms of an AP is this, where p and q are constant, find the common difference. Let a1, a2 till an are in AP, then what you get, sum Sn is equal to this one. This is given as np plus half n minus 1 q. So S1 is a1, okay, a1 which is p, and S2 is a1 plus a2, that is 2p plus q. Okay, so what you get here, this is actually, you are just referencing to them. So a2 is nothing but S2, this S2, whereas S1, what you get, p plus q. So the common difference D is nothing but a2 minus a1, which is p plus q minus p, that is q. So this is how you get, right? How about the sum of n terms of two arithmetic progression are in the ratio this to this? Find the ratio of their 12th term. So the sum of n terms of AP, sum of n terms of second AP, 3n plus 8 by 7n plus 8. This is what? N by 2, 2a1. We take a1 and a2 are the first terms of the two progression. d1, d2 are the common difference of two progression. So this is n by 2, 2a1 plus n minus 1 into d1. This is n by 2 plus into 2a2 plus n minus 1 into d2. So what you get? You get this one. And the 12th term of this progression is a1 plus 11d, a plus a1 plus 12 minus 1 into d1, like this. So it will be a1 plus 11d1, a2 plus 11d2. Here in 1, just place n equal to 23. What do you get? 2a1 plus 22d, right? Similarly like this. So just take 2 common. So it will be a1 plus 11d1, a2 plus 11d2. So this is when you place 23 here. It will be 3 into 23 plus 8, 7 into 23 plus 15, that is your this term, that is 7 by 16. Now the income of a person is 3 lakh. The first year receives an increase of 10,000. So A is this, D is this, and to his income per year for the next 20 years, find the total amount he receives after 20 years. That means we are being asked n equal to 20. So we just used this formula, 20 by 2, 2a means 2 into this plus n minus 1, like means 20 minus 1 into d. D is 10,000. So it will be this much. Arithmetic mean. So we have two numbers a and b. Now we can insert value between a and b, a, capital A, such that it is going to be the arithmetic mean. How arithmetic mean? This is this a minus a will be equal to b minus a, like this. So you get capital A as a plus b by 2. So you can insert a plus b by 2 between two numbers, and there can be a question in your mind: can I have more than one value between these two? Yes, we can have easily. So there can be as many numbers as you would like, resulting in a sequence in AP. Like if you have a1 to an, this is a sequence. A and b is your starting and end. So a and b, how many terms are there? A1 to an is there n terms. One is a, one is b. So there are n plus 2 terms in all. So what will be the b? B is actually n plus 2th term. So b is equal to a plus n plus 2. This is n plus 2 minus 1 into d. So b is a plus n minus 1 into d. So what you get d here? B minus, you just rearrange this. B is b minus a by n plus 1. You get a1 as a plus d, a2 as a plus 2d, a plus 3d, a plus md, and d is what you have got here. And just taken question, you want to insert 6 numbers between 3 and 24. So in all, how many numbers are there? 6 in between and this one. So there will be 8 numbers. So 3, A1, 2, A6 and 24. So A is 3, B is your this 24 and N is 8. 8 numbers in all. So 24 is what? A plus N minus 8 minus 1 into D, D equal to 3 bit. So the numbers are A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, A plus 6D. You place the value, you get this value. Okay, so this is the first part of the sequences and series. We'll be taking a few more of these. Thank you so much.